Okay. All right. Hi, everyone. Today is July 15, 2021, and welcome to this week's SIG scheduling meeting. And this meeting is being recorded and will be uploaded to YouTube. So looking at today's agenda, first one is the GSOC proposal, which was tried to create a web-based simulator for the Kubernetes scheduler to sort of, I think, visualize every decision, every scoring, filtering result of how scheduler does under the hood. So let's give me the control to Kensei. I'm not sure if I pronounced it correct. Correct me if I'm wrong. Yeah, Kensei, could you see if you can share? If not, I will make you the co-host.
Okay.
Yeah, give it a try.
Yes.
You can, okay?
I can share. Okay.
Okay.
So let's start.
Please go ahead. Yeah.
Okay. Can you see my screen?
Yes, I can.
Thank you. So, hello. My name is Kensei. GitHub ID is sample Siho. And yeah, most important part is I'm not good at English. Yeah. So please speak me with very, very slow English. And I'm working on this issue as the Google Summer of Code project. And I'm going to give you a brief overview, and after that, I show you some demonstration. First, it can create this resource, and so we can simulate scheduling that depends on like PV or PVC, and we can see scheduling result. So we can see how the scheduling is done. Yeah, so let's see the demo. So this is start screen, and after push start simulator button, it create namespace for this user, and we can create some node, and yeah, of course we can delete or edit some part. And so if I try create some pod, yes, we can see this pod is scheduled on this node, and then we can see how it's scheduling. We can see the filtering foregoing result and the score and normalized score. Yes, and so for example, we can create like, let's see. Like this, and also we can create TV like this, and we can create new bot with the volumes. Then these volumes, this volume is bad, and this bot is scheduled on this node. Yeah. So this is all of our simulator, our simulator's feature. Thank you.
Yeah, thank you for the demo. It's very impressive. And I suppose this project is still ongoing, right? Does this mean the
yes.
finish of the project? Okay, it's still ongoing. And
yes.
When you create a new pod, which kind of spec do you support? For example, you specify the CPU and memory request. That is the basic one. So do you also support some like advanced scheduling feature like pod affinity, node affinity, or sort
of? So we can specify CPU or memory to create node or create new pod.
Yeah, do you support any other advanced feature like pod affinity or pod topology spread constraints? So is that on your working list or it's already implemented?
Is already implemented.
Okay, cool. So yeah, if you can demo advanced example, that would be great for like your.
Okay.
Yeah.
So
perhaps you can give an overview of how is this working under the curtains. Like in particular, I'm interested to know. Well, I assume you actually have a real API server running, and then the scheduler. Yeah, how is it running?
So this on this background, I run API server locally and create scheduler and create PV controller. So when the pod is created, this backend requests to API server to create pod, and then the scheduler start to schedule the pod with some resources.
Cool. So to clarify, so the API server is a real API server, complete binary. The scheduler, is it also the entire binary that you're running, or is it running you're copying some of the code?
Backend is one single binary, and I create API server and scheduler within single binary and run only one backend binary.
Oh, does that mean if you create 100 nodes, you will have a real cluster to to get those 100 nodes created?
No. I don't run. No, I don't create Kubernetes or some resources. So sorry, I create only API server and scheduler and people controller. So no cluster is running, and we can see scheduling result from API server and not real cluster.
So I'm not sure I follow exactly. So does that quite similar like how we run the integration test? So we just call the scheduler and controller API to start them. So okay, that's not real cluster. Yeah, that is if it's a real cluster, it doesn't. It's sort of pointless to simulate the creation. So in terms of the simulation, so what about API server? Do you start a real SSD or just call the pure API server SDK?
Sorry, one more time, please.
So the question is, I mentioned that if the backend architecture is like how we run an integration test, you'll say yes, right? But yes. In integration test, we need to because API server is pretty difficult to mock, to simulate. So in the integration test, we start the etcd binary in the backend, and the API server is sort of like a real API server. So how do you do that in your project? What about the dependency on API server and the etcd? Do you run etcd as a real binary?
Sorry, what is ASP?
etcd. Let me type it here.
Just jump in. Yeah, he does. He is starting a etcd instance that runs along with his simulator.
Server. Okay.
Yeah.
Okay.
It's almost very similar to how the integration tests work, except that instead of measuring performance, we just use the output of the scheduler to display that in the web-based interface. There are also some minor changes. For example, if you schedule a pod to a node, there are annotations that are added to the pod to tell you what the score for each plugin was, what the filter result was, etc. This is obviously not a part of the integration test, but the simulator does that so that it retains information about the score and filter results and so on, which is what you see in that table when you click on a pod.
Yeah, I was going to ask about that. So the storage is all in etcd, even the scoring.
Yes.
So the scores and filters, so did you modify the scalar code to do this, or how?
No. No. Okay. So
just a high level idea is fine. You don't have to explain the spinous details, but just a high level idea.
So your question is how I record score or filtering result?
Yes.
Yeah. It's on annotation like this.
What writes the annotation?
Yeah. So on my backend, it creates plugins to record the scheduling result for each default plugins, and then they record on this annotation tag, and front end show the result from this information.
Okay, yeah, that's good to know. So I assume this will have, so you're modifying some of the code, some of the scheduler code to do this.
No, I create new plugin and disable all default plugin, and I enabled I enable new plugins to record the result. So I don't touch scheduler code, but I just use my plugin to run when
And the plugins,
it's
they call the real plugin code.
Yes.
Okay. Oh, that's cool. All right. Yeah.
I think it's valuable to get this design and implementation tips and tricks in a document. So yeah, the readers and the other guys who are working in the same similar idea can leverage can benefit from what you have done. Is there a detailed design document or implementation document? Yeah, recording this kind of stuff, like how the backend architecture is like, how you implement the plugin. So we don't maybe need the so detailed, but need the high level stuff. Yeah, that can benefit the other users.
Okay. So where should I write document?
I think along with your GitHub repo, there is a design doc folder or something. Yeah, you can put it, your idea, how you implemented this project there. Yeah.
Okay.
Just to add a little bit more, so Kensei is around the halfway point in his project. There's around 4 or 5 more weeks left in his GSOC in this GSOC project, and even though he's like well ahead of schedule, so we originally didn't have the plan to have filter and score result, etc., a part of the first half of the project, but he's already ahead. So which is why we already have all this already done in the project. But yeah, definitely documenting how it works and how to run this is probably very important. And I think Kensei will probably do that sometime before the merge into the main repo. This is all structured as a command line binary, by the way. So it's all under the CMD directory in his own fork right now, but eventually it will probably be a part of the main repo.
Yeah, so I'm not sure if we will be able to put this in main repo, but it could certainly be a project just like scheduler plugins.
Yeah, definitely. Yeah. It doesn't have to be the main repo at all.
Yeah. One nitpick here, I don't think we need the normalized underscore. We probably just need the final, which is the normalized. I think that's good enough. But I was going to say this is great progress. I'm really impressed with the demo.
Thank you.
Yeah.
Yeah,
thank you.
I really appreciate the efforts. So before you end the demo, could you give another example to see how an unscheduled pod looks like? Like you request a 1000 CPU and how it looks like.
Okay. So create a new pod and request super big memory.
Yeah.
And then.
So
Oh.
yeah, how can I visualize I know where is my pod and what reason?
Sorry, so no. So
Yeah, no worries.
now it don't work well, but previously I
It works, but I've seen it before. There's another separate section for unscheduled pods, but
yes,
but yeah, he's actively developing this, so I imagine that's fine.
So
yeah,
now
so basically what I expect is that I expect the pod to still show on the web page, right? But maybe just mark with a red backend, and if you click on the pod, you can see the failure reason. And that's basically what
yes,
I want.
So I so something goes wrong. But when put failed to schedule root, it will show on new column unscheduled pod, like unscheduled pod, and we can see result. Yeah, we can see why the pod cannot be scheduled from this filter column. But now something goes wrong with this simulator. Sorry.
No, I have one final ask. It would be
Yes.
nice to be able to configure the scheduler so that you can disable some plugins.
Yeah.
The weights and things like that.
So
yeah, that would
yeah,
be useful if you have enough time left. I think that would be cool.
Yeah. Okay. Yeah. Thank you.
He has that plan, so he has a plan to make it arbitrarily configurable. You can change the scheduler config and profiles and so on. But that's a part of the second phase of this project, which is just starting sometime this week. So yeah.
Excellent.
Yeah, thank you, Kensei, for working that, and thank you for Aditya for coaching all the way and to make such progress here.
Thank you.
Yeah, thank you for that.
Thank you very much.
And, let's continue the agenda. So the second agenda is that there is test failing on the 122, which is part of void node. Void node. I think it's a annotation and controlled by a score plugin, right? Oh, not sure if Mike or Ravi is on the meeting, but I think there's some changes to improve this. Yeah.
We now V1 beta 2 is the default, and in V1 beta 2 we don't have this plugin anymore.
Okay, so that means that we should remove this test?
Yeah, I think so.
Okay, so yeah, could you could you raise a PR to remove this, and also confirm with maybe Mike or with Ravi to see if it has the impact with them.
Sounds good. Yeah, I'll ping to them. But yeah, the feature's still there. I mean, they can still re-enable it, but ultimately, yeah, you have pod affinity and node affinity and whatnot. And toleration. So this, yeah, we should get rid of this feature for sure.
Okay. Yeah.
But yeah, I'll do the PR.
Okay. Thank you so much.
Mm-hmm.
Yeah. All right. So last week we had the code freeze. So only the critical fix or sort of BRs fixing the flaking test can be eligible to merge. So yeah, be aware of that. Yeah, some trivial PRs will be wait for the cycle 123. So yeah, and before I end today's meeting, so is there any ideas you want to raise up? We have still 2 minutes. Okay, if no, I will give the 2 minutes back to you. And thank you for joining today's meeting, and I will see you in the next 2 weeks. Thank you, everyone. Have a good day.
Thank you.
Bye.
Thank you very much.